Assalamualaikum semua. Okay, so here's a question that I have chosen from the past year question. Okay, that will apply the concept of thin films. Okay, so first of all, this question you are provided with a diagram. Okay, usually soalan untuk thin film ni sama ada dia bagi diagram ataupun dia tak bagi diagram. Okay, so if the diagram has been provided like this question, so it makes it easier for us because we can already see which layer urutan dia tu. Okay, if the question does not give you the diagram, you have to sketch, okay, to see the sequence urutan layer itu. Okay, kat mana refractive index yang disusun. Okay, so what we have here, figure 6 shows a flint glass lens of refractive index 1.61. Okay, so that means this layer here is coated with a thin layer film of magnesium fluoride with index 1.38. Okay, so dalam arti kata lain, coated ni bermaksud meliputi. Okay, so dalam arti kata lain, the glass lens, okay, dilitupi oleh magnesium fluoride ni. So sebab tu 1.38 the thin film, okay, of magnesium fluoride ni is on top of the glass lens. Okay, and like I said, air, okay, will always be the first layer. Okay, sebab light will originate from air. Okay, and then given to us the wavelength of light is 565 nanometer. Okay, so by the way, the first question, to sketch the light rays that interfere after being reflected tu is already out of syllabus lah. Okay, so kita nak tackle sekarang ni soalan yang nombor 2. What minimum thickness should the magnesium fluoride film that has n equals to 1.38 tadi tu, okay, have if the reflection of the 565 nanometer light is appearing dark. Okay, so keyword kat sini adalah appearing dark. So that means appearing dark ni sama maksud dengan destructive interference. Okay, so bila disruptive kita nak kena consider which equation do we apply? Is it 73 or 74? So before we identify 73 or 74, the equation to use tu, kita kena tengok kita punya layer dulu. Okay, so our layer starts from air 1 ke magnesium fluoride 1.38 and lastly to the glass lens 1.61. Dalam arti kata lain, the area keeps on increasing. Okay, 1.61 is bigger than 1.38 and bigger than 1. So maksudnya dia akan jatuh bawah first case lah. Okay, so first case tadi yang kita tengok adalah the the left column tu. Okay, if you refer to the previous video, okay, it is on the left column. Okay, so when we have disruptive interference, okay, that means we will be applying equation number 74, which is 2nt equals to m plus half lambda. Okay, since it is under first case, okay, and we want a destructive interference. Okay, so here we already have the refractive index for the thin film, which is the magnesium fluoride 1.38, and this is the T that we want to find, the minimum T. So minimum thickness will correspond to the lowest number of order, and since the equation is m plus half, that means the lowest number of order will be 0. Okay, sebab kalau kita substitute 1, itu dah order yang seterusnya. Kita nak yang paling minimum. Okay, since T and M, thickness and number of order are directly proportional. Sebab tu minimum thickness correspond to lowest order. Okay, so darabkan dengan 565 nanometer. Okay, so you can solve to get your minimum thickness. Alright, so that's how we apply the concept for thin film. Thank you.